Software Package Solutions. Commercial off-the-shelf, COTS. There are times when it is not feasible to develop new software from scratch, and it is preferable to use a software package that already exists. These are known as commercial off-the-shelf, COTS, solutions. These solutions are provided as is, meaning that you pay for the software that is already developed and ready to go. Support of some kind is usually included. They may save time, but it comes at a cost of not being tailored specifically for the business. Component-based development. This is where software applications are built using components, which can come from a number of sources. This development type takes advantage of code reusability. Strengths. Time save. Uses dry principles. Cost. The reduced time saves money on resources. Improved quality. Using components that have already been in live use reduces the risk, as bugs have most likely already been found and dealt with. Weaknesses. Harder testing. Unknown uses of components brought in from outside source. Middleware. Technologies could be incompatible. Bespoke development. This is a method of producing software that doesn't prescribe to common theoretical approaches. Software may be developed using variations or combinations of methodologies. Businesses choose aspects of approaches that best suit themselves and combine them to form a customized development practice to give maximum benefits. The disadvantages is that organizations may do whatever is cheapest, meaning the most appropriate practices may not be followed. Application lifecycle management tools. With system development being more complex nowadays, tools exist that can help through all stages of the development process. Benefits of tools. Standardization. The use of templates, specific notation, and forms for written documents ensures that any team member can pick up where another left, as the process is standardized and the quality of the developed product is always maintained. Storage. Creating computer-based files rather than paper ensures not only higher security, but storage space is relatively unlimited, as no physical capacity is enforced. Availability and security. Typically, electronic documents and repositories can be accessed more readily than paper counterparts. With electronic documents you can control the access levels and privileges easier than paper. Version control, source control. As elements evolve over time, the ability to maintain multiple versions and roll back when needed is vital. Recording who made changes, when, and what is vital in bug corralling and maintains independent responsibility. A good example of a version control tool is GitHub. Version control tools typically allow multiple people to work on code simultaneously, whilst keeping a central version. They also allow each stage of development to be saved separately, different branches of development to take place, and allow developers to keep track of changes and revert them when needed. Impact analysis. A tool can use links and cross-references to provide useful views and reports about elements, such as matrices and traceability reports. These help during change control through an impact analysis. If a change is made on a particular element, tools are quick to find other elements that may also have to change. Configuration management. A configuration is a set of related configurable items, each with a specific value or setting, which need to work in specific combinations. Being able to apply effective change control management to these is integral, particular with complex systems. Pitfalls of tools. Tools are only as useful as those who use them. If you get a tool you know nothing about, you are not likely to reap the benefits of said tool. There is also the danger that too much trust is placed within a tool, that anything output by said tool must be correct. What to consider when selecting tools. Requirements. What do you expect the tool to do? Functionality. Be cautious of lists of features, they can be exaggerated by marketing. Look within the business and see what particular roles can do with the tool. Suitability. Does the tool meet business standards, or will the business have to change processes and notation to align with the tool? Compatibility and technicality. Is the tool compatible with existing operating systems? What is the technical requirements for the tool? Cost and skills. Is there a cost, or is it open source? Do users of the tool require training in order to be effective? CASE stands for Computer-Aided Software Engineering, and covers everything from requirements to testing. Within CASE there are specialist tools. CARE. Computer-Aided Requirements Engineering tools are specialized tools that can sometimes operate as a standalone tool, or as a function of a broader business modeling or CASE tool. They can make a lot of things easier, including version and change control, team support and access security, traceability, configuration management, business modeling. Tools that support business modeling and architecture help to develop, implement, and maintain the models and architecture within, such as business functions and services, context and links with economy, internal structure and roles, information systems, IS, and information technology, IT. In this context, IS/IT are components that provide services to the business and perhaps direct to customers. As the business seeks to change its model, it often requires a change in the IS/IT. Project management tools. Project management tools tend to focus on planning, resource management, and progress reporting. System modeling tools can be used by a number of roles such as business and systems analysts, designers, and developers. These modeling tools support model-driven engineering, which is the process of proving from abstract models of a system through to an implemented version of said model. The diagram below demonstrates how older techniques created a new system, called a U-curve. Testers can also use these models as a basis to analyze and design the testing, or integrate these tools with other testing tools they're using. CAST stands for Computer-Aided Software Testing, and there are different tools for different types of testing. They do more than run automated tests. Some other features include test management. Allows managers to plan, review and report on a testing program. Test design. Allows testers to analyze requirements and design to design an appropriate level of testing, including design of test scenarios, sample data, and boundary tests. Test analysis. Allows testers to review the results of a test and determine what feedback to provide the developers about defects, and changes to make to the test designs to increase the effectiveness of the tests. Software development tools. Development tools enable developers to take a design, and either write source code or use a visual notation that links components into an assembly to which source code is automatically generated. A good example of this is Lucidchart. Integrated Development Environments, IDE. Code then needs to be able to be executed by the computer. There are various tools for this which fall into two main categories, interpreter or compiler. Interpreter. Here source code is interpreted as a set of instructions at runtime. The software that does this is known as a translator. For example, JavaScript embedded on a site is interpreted by the browser. Compiler. Code here is compiled and linked to produce native executable code. Source code is taken through a two-stage process, where it is first compiled into an intermediate link code, which is then linked to similar code in statically linked libraries to produce a version of the code that is directly executable by a specific platform. Typical features of development tools include syntax support, integration with repositories and version control, highlight errors, model-to-code support, service management tools, also referred to as IT service and support management tools, ITSM. These tools are useful for after a solution has been released, as after its release it still requires monitoring against service levels, support through help desks, documentation of what is deployed and business as usual, BAU, maintenance. A configuration management database, CMDB, is a key feature of any ITSM. Service level agreements, SLAs. This is an agreement between two or more parties, typically those who build or maintain a system and their customers. It is used to define things such as time to respond to a request for support. There is a contract between parties that agrees to provide the service to a predefined level and/or standard. Penalties may be imposed if the SLA is not met. A skeletal model in which only lines and vertices are represented.